22. Determine the convergence radius of the following power series and calculate their sums. Okay, so let's do the first one. Sum from n equals 1 to infinity of x to the n divided by n. Well, if you compute the convergence radius using the root test here, we have the limit when n goes to infinity of the nth root of the absolute value of x to the n divided by n, which is x has to be smaller than 1. Okay, so the convergence radius is 1. Okay, the convergence radius rho is 1, and the convergence is only convergence in absolute convergence in -1, 1, because if x is equal to 1, this is the harmonic series, so there is no convergence, right? So now what happens? What is this series? Well, this is x plus x squared over 2 plus x cubed over 3 plus and so forth. And yeah, you will see this is very similar to the logarithm of 1 plus x. It's just that some terms are positive when they should be negative, and that's because this is the logarithm of 1 minus x. Okay, and minus the logarithm of 1 minus x, right? If you remember, the logarithm of 1 minus x is minus x squared minus x cubed. So this is the sum, right? The second one, you get the sum from n equals 0 to infinity of n plus 1 times x over 2 to the n, right? If you do this again, the root test, you have the limit when n goes to infinity of the nth root of x over 2 to the n times n plus 1, and the limit of this is 1, so this you have x over 2 has to be smaller than 1, so the absolute value of this. So then x has to be, the convergence radius is 2, the convergence is in -2, 2, right? And again, if x is 2, this is 1, so this is the sum of the natural numbers, and that goes to infinity, right? Now, what's this series? Well, you can write it like this. This is the sum from n equals 0 to infinity of n plus 1, and let's say it's t to the n, right? Now, we know that this is the derivative of this t to the n from n equals 0 to infinity, right? You can check if you don't believe me, right? Now, this is equal to 1 over 1 minus t, right? So the derivative of this, right? Let me erase this. The derivative of this is so the sum from n equals 0 to infinity of n plus 1 times t to the n is equal to the derivative of 1 over 1 minus t, and we have seen this before. This is 1 over 1 minus t squared. Okay, another way to see this is that, remember, this is the formula. This is a arithmetic geometric series. So if you remember the formula for this, you will see that this is the same, right? Now we substitute here t is x over 2, so we have 1 over 1 minus x over 2 squared. So then we can multiply and divide by 2, right? So this is 2 divided by 2. We have 4 divided by 2 minus x squared, right? And the convergence, so this is the sum. This series is equal to this only in this interval, okay, -2, 2.